Okay, in this video we're going to talk about in behavior the graphs of polynomials, and we're going to graph some here in a second. So first let's start out by looking at the in behavior. If you have an even function, the even function is determined by your largest exponent being even. Okay, so like in terms of this first one, this is the largest exponent we have right here, and it's an even number, so this would be considered an even degreed function. Okay, if the leading coefficient in front of that is positive, this is not, this one is. Okay, so if the leading coefficient in front of it is positive, then it's going to, the in behavior is going to look like this, kind of like a parabola looks, but there might be, as the degree gets higher, there might be some more stuff going on in between here. And if it's an even degree but the leading coefficient is negative, then it's going to be like this. Okay, and then for an odd degreed function like this one, it's one that has the highest degree being odd. Your in behavior, if the leading coefficient is positive, is going to be like this. Okay, and if it's an odd function, so the exponent, the biggest exponent is odd, and there's a negative number in front, it'll be the opposite of this. So it will look like this. Okay, so that's the in behavior and how you tell. So let's look at the first one. Here's the biggest exponent right there. So we have negative 4x squared. So since it's negative and its degree is even, that's this one. Okay, so the left is going to go down and the right is going to go down. So which one of that is this? It says right here falls to the left and falls to the right. So that's what this one would do, because it's negative and its exponent is even. So negative and even right here. Okay, this one is odd because the highest degree is odd and the number out in front is positive. So odd and positive, which means the left goes down but the right goes up. Okay, so falls to the left, rises to the right, that's the one. Okay, now let's look at this one. Okay, so this one, to figure out what the degree is, you have to look at all the different exponents. So you could multiply this through if you wanted, but if you look at, you're eventually going to have to multiply the negative 4x times the x times another x. So your leading coefficient is going to be 4x to the third power. Okay, because that's negative 4x times x times x. Now you're going to have a bunch of other terms out here if you multiply this all through, but if you just look at the leading one, this one gets multiplied by this one gets multiplied by this one is going to be your biggest term in terms of exponent. Okay, so it's odd and negative, that's this one. Okay, so that means it rises to the left, falls to the right. Okay, and then for the last one here, we've got our leading coefficient is the 2x to the fourth. Okay, that is positive right here, and the coefficient, or the exponent here, is even. So positive even looks like this. So it rises to the left and rises to the right. Okay, there's that. Okay, a couple more here. So this one has, the biggest one is an odd power. Okay, and the leading coefficient is negative. Okay, so leading coefficient is negative and it's an odd power. So odd and negative means it rises to the left, it falls to the right. Okay, and then finally on this one, again, we're going to multiply just the first term times these two terms. So x times 5x is going to be 5x cubed. Okay, that is odd and positive. Odd and positive, it falls to the left, rises to the right. Okay, so that's this one. Alright, so let's use the in behavior and let's see if we can graph some of these functions. Okay, so on this one it says determine the in behavior and intercepts of the graph of a polynomial function. Okay, so we look at, is it an even or odd degree? We're going to find the x and y intercepts. We can talk about multiplicity, and we'll see if we can graph this thing. Okay, so the first thing that we need to look at is what's the in behavior. In order to find the in behavior, like we did previously, is we multiplied x times x, but this one is getting squared, right? Okay, so this one's going to be x times x squared times x. So our leading coefficient is going to be x to the fourth power. Okay, so x to the fourth power means it's even degree, and since the number in front is positive, a 1, then it's going to rise to the left and rise to the right. So it's going to look like this with some stuff going on in the middle. Okay, now recall that if the degree of the 0 is even, then you're going to bounce off. Okay, so like this one, this x plus 1, which would solve to be x equals negative 1. This would bounce off the x-axis instead of crossing because it's an even power. These other two, x plus 2 and x minus 1, would cross the x-axis because they have odd powers. Okay, so for the zeros, we'd find 3 zeros. X plus 2 equals 0 gives negative 2. X plus 1 equals 0 gives x equals negative 1. That's the multiplicity 2. Say m2 there. And then x minus 1 equals 0 will give you x is equal to 1. Okay, so the one that has the degree 2 is the one that would bounce. So at x is equal to negative 1, it bounces off the x-axis. Okay, and it crosses the x-axis at negative 2 and 1. So x equals negative 2 and 1. Okay, we can draw all three of those on there. Okay, so here is 1 where it crosses. Here is negative 1 where it bounces. Okay, and here is negative 2 where it crosses. Okay, so we've got our x-intercepts and we know what they do. You can look at your y-intercept. The y-intercept comes from setting x equals to 0. So if we take f of 0 to find our y-intercept, we would get 0 plus 2, 0 plus 1 squared, and 0 minus 1. Okay, so that's 2 times 1 times negative 1, which is negative 2. So we'll cross at negative 2 right here. Okay, so let's put this all together. We know the end behavior. We know that we're starting from up here. Okay, and we know it's going to sort of look like a parabola at the endpoints, but we have some stuff going on in the middle. Okay, so if I'm starting up here, I need it to look like this. So at negative 2, it says I'll cross. Okay, and I can come down here and then come back up. And at negative 1, I bounce. Okay, and then I'll cross somewhere over here. And then I will rise up and cross again at 1. Okay, so the end behavior looks like this. Okay, we found our x-intercepts right here, found our y-intercept right here, and remember the cross or bounce. If it's an odd power, then it crosses. If it's an even power, it bounces. So this should be relatively close to what the graph looks like. Okay. Okay, and I went ahead and graphed this in my TI-84 Plus. Okay, here's what I typed in. X plus 2 times x plus 1 squared times x minus 1. Okay, and there's what the graph looks like. Okay, so it crosses at the negative 2, bounces off here, crosses the negative 2 on the y-axis here, and then comes up and crosses at x equals 1. Okay, let's take a look at this one. All right, so the first thing we want to do is figure out the end behavior. Okay, notice we have a negative out front. Okay, and to get the degree of this thing, we multiply the leading terms here, the x times the x times the x squared, because of this. So it's going to be negative x times x squared would be our leading one. So it would be negative x to the fourth. Okay, negative because the negative's out in front here, and all the rest of them are positive. So our leading term is negative x to the fourth. That means it's going to look like this. Okay, sort of like an upside down parabola, except with some other stuff. Okay, now remember, if you have a 0 that has degree 1, like this one and this one, the exponents are 1, then it crosses. But if you have an a 0 who has an exponent of 2 or 4 or whatever, an even powered one, then it's going to bounce. So these two, x minus 1 and x plus 1, We solve those both, so we get x is equal to 1 comma negative 1. They cross. And then x is equal to 2, which is this one if we set it equal to 0. It bounces. Okay. We can also look at the y-intercept by plugging in 0 for all the x's. So it would be negative 0 minus 1, 0 plus 1, and then 0 minus 2 squared. Okay, so this is negative times negative 1 is 1, and then 1 times 1 is still 1, so it's only this term that we have to worry about. That's negative 2 squared, which gives us 4. So the y-intercept will be negative 4. Okay, so we found our x-intercepts, we found our y-intercepts, we found our end behavior, and we found where it crosses and where it bounces. Okay, so we'll be starting down here because this is what the end behavior looks like. So I'll start down here. Let's cross my, let's label my x and y intercepts. Okay, so I have one at negative 1, and then I have one at positive 1. Those are the two that cross, and then the one that bounces is at 2. And then our y-intercept is negative 4. Okay. So we're going to start down here. We're going to cross here. Okay. And then come back down. Actually, no, I made a small error. This should not have been negative 4. I said it was 4, and then I wrote down negative 4 here. Okay, so when we set all this equal to 0, all the x is equal to 0, the negative 2 squared became 4. So we don't have a y-intercept down here. Our y-intercept is actually up here. It's going to make a little more sense than being down there. Okay, so this is not part of the graph down there. Okay, so we are starting down here because of the end behavior. We'll cross here at negative 1, and then we will cross the y-axis here and start going back down. Okay, so let's start that. So up, and then we cross the y-axis, we start going back down. Okay, and it says at positive 1 we cross as well. Okay, so we start going back down right there, and then at some point we start it doesn't cross there, it bounces. Okay, so it looks like this. Alright, so I made a couple mistakes in that, so let's recap real quick. So here we cross, and here we cross, here we bounce, because it has degree 2. Okay, so we start here on the end behavior, it goes up, it crosses the y-axis, starts going back down, and then crosses again at 1, and then at some point it goes back up, bounces off the x-axis, and goes back 1. So if you cover up this part, you'll notice that the end behavior looks like a parabola, but with some stuff going on in between. Okay, let's do another one. So the end behavior on this, we look at the leading x terms. So this is an x, this will be an x squared, and this will also be an x squared. Okay, so that's x to the 5th. There's no negatives to worry about, so this is a positive but an odd function. Okay, so the positive odd function will look like this. Okay, now for the zeros, these two have degree 2, which means they're going to bounce. Okay, so when we set those equal to 0 and solve, that'll give us 1 and negative 1, and they're bouncing because they have even degrees. So x is equal to negative 1 and positive 1. And this one has degree 1, so it crosses, and that's going to be x is equal to negative 2. Okay, the y-intercept, we plug in a 0 here, and we get 0 plus 2, 0 minus 1 squared, and then 0 plus 1 squared. Okay, so that's 2 times 1, because you square negative 1, it becomes 1, times 1, so that's 2. So y equals 2. Okay, so let's mark these. So 2 is where I cross the y-axis. I've got one at negative 1 on the x and positive 1 on the x. Okay, and then I've also got one that crosses at negative 2. Okay, so it needs to look like this. It needs to start from down here. It needs to cross, bounce, bounce. Okay, so it's going to bounce at negative 1 and at positive 1. So the only one that it's crossing is down here. So go like this, cross, and then it bounces, and then it bounces like this. Okay? So only the one place does it cross is at -2. The other two, it hits the x-axis and then bounces off. Okay? So this is what that should look like. All right, let's do one more of these. Okay, so we've got, to find the end behavior, we multiply the negative out front times the x here, times the x squared here, and times the x here. And that gives us -x to the 4th. Okay, so that is negative and even. Negative and even means it looks like this. Okay, so that's what the end behavior is going to look like. Okay, now let's see, the ones that cross are the ones that have the odd powers. So that's this one and this one. X plus 3 gives us a solution of -3, and x minus 1 gives us a solution of +1. This one has degree 2, so it's going to bounce. So that's x equals -1 you will bounce on. And then to find the y-intercept, you do f of 0 equals -0 plus 3 times 0 plus 1 squared times 0 minus 1. Okay, so that gives us -3, the negative and the 3. 1 squared is 1 times a -1. Okay, so that'll give us 3. So y equals 3 is our y-intercept. 1, 2, 3. Okay, and then -3 on the x, we cross. 1 on the x, we cross. And -1, we bounce. Okay, so cross, bounce, cross. Okay, and we need to look like this. So we'll start down here, and it's cross, go back down, bounce, cross. Okay, and that's the last problem. But one other thing that I should mention before we're done with this is that if you look at the highest degree, x to the 4, then you're going to have one less turning point than the biggest degree. So what I mean by this is x to the 4 power. 4 minus 1 is 3. Okay, so how many hills do we have? We have this hill that goes up, this hill that goes down, and this hill that goes up. We have 3 of them, right? Okay, so x to the 4 is going to have 3 of the hills. Okay, like this one, the highest power was x to the 5, so we should have 4 of the little hills, right? So 1, 2, 3, 4. So it's going to be 1 less than the biggest power. Or on this one, it was x to the 4, so there should be 3 hills. 1, 2, 3. Okay, so it's always going to be 1 less turning point than there are a degree of a function.